7, 2, 14, and 4, right? And 4. Okay? So that is the question there. I forgot to put my given. Goodness, oh, did I forget that? Just remember the numbers, guys. All right, given G 7, 2, 14, 4. Okay. All right, so let's look at this one now.
For the
CM
sign there.
process. Huh?
They are not quite sign. They are not quite sign.
What do you mean sign? These one are all
Like
positives.
negative. Oh,
These are
okay,
all
that was us.
positives. All right. So the
Us.
first one was all negatives. This one is all positives. Then the next one
Oh,
I'm
okay.
gonna do will have some positive, some negative. Okay.
Oh, okay.
All right. All right. So here let's begin. So we're gonna have the determinant of J, AD minus BC. So the determinant of J will be 7 times 4 minus 2 times 14. So the determinant, oh goodness, what just happened? You see, that's the thing with this. All right, the determinant of J then is 28 minus 28. So the determinant of J is
Zero.
0. So this is singular, and we can see automatically there is no inverse, right? There is no inverse. Because remember, in a singular matrix, there isn't an inverse. And we said last time that the reason there is no inverse is because of the 1 over 0, right? Because of the 1 over 0. Because 1 over 0, of course, is undefined, or we say it is infinite.
Infinite.
Yeah,
Yeah.
I stay as is, right, sir? Because
that's
you
it as
said
it is. Yes,
okay.
that's the end of that question right there. So
4
F,
negative 176.
all right, given F 4 negative 1 7, is the 6 negative? I think the 6 was negative. Yes, the 6 was negative. All right, good. So let's look at this one. So you have number 3. It says F is equal to 4 negative 1 7 negative 6. So E, F is equal to AD minus BC. So F is equal to 4 times negative 6 minus negative 1 times 7. So the determinant will be negative 24 plus 7. But remember, we have to read it as 7 minus 24 because the positive has to be read first. So when I subtract that, all right, I am going to get negative equals negative 17. So this is, of course, a non-singular matrix, right? So that's A.
So, sir, when you have negative, like the negative and the positive, you will still subtract, right?
Yeah, it's still subtract. Just have to keep the
7
sign of the larger number. All right.
Yeah.
All right. Then B. Then F adjoint. I try to switch these and alternate into notation so that you get used to seeing the different forms of notation. And so we're gonna have EMD, negative B, negative CA. So here the 4 and the 6 will change place. So the 6, the negative 6 will go to the top and the 4 will go to the bottom. Now here, notice the B, the negative 1, is a negative. So when I write it, I must write it as a positive. And the 7 here is a positive. So when I write it, I'm gonna write it as a negative there. All right. Questions?
No.
All right. Just
So, sir, because the C, the 7 wasn't negative, then you put it as positive, right?
how?
The answer for the adjointment,
Uh-huh.
-6, and then you have -7 underneath. You get -7 because it was positive, right? Then you turn it to negative.
Exactly.
Okay.
Exactly. Yes. Yes. Very, very true. What the? What is going on here? Goodness, this is giving me a bit of a hard time when you don't have your toolbars. Oh, I don't
Yes,
understand.
because the D, you barely write it. You see it, sir?
Yeah, yeah, I know. I'm trying to fix this thing. I think I know what's, yeah, that's in the way. So the 4, the -6, -1, and +7. All right. Yeah, so yeah, the D I kind of botched it up. Yeah. So let's look at the last part. So C, F